All right, and welcome back. So today we are going to be continuing our conversation of how to write equations in slope-intercept form. But first, let's work on a quick do now. What is the equation of this line? Remember, we're using slope-intercept form, y equals mx plus b, to write our linear equations. So please, inform us. What is the equation of this line? All right, so one of the first things that we are able to calculate on this line is the slope. We are given 2 points that are on the line, and we can calculate the slope between them. The slope is the change in y divided by the change in x, or how much we go up and down compared to how much we go to the right. Well, if we start to count, we go up 2 units and right 4 units, so our fraction turns into 2 over 4, which we can simplify to 1/2. Therefore, the slope is going to be 1 over 2. So that's the m value. So now we have to find the intercept, the b value. Well, we want to see, where does our blue line strike that y-axis? Well, if we look at it, we can see it hits that y-axis at 0, -3, which means the y-intercept is -3. If we piece these all together, our m is our slope, which is 1/2. Our b is the y-intercept, which is -3. So we piece it all together, and we get y is equal to 1/2 x minus 3. Notice how we were given 2 points that were on the line. We were able to calculate the slope. We were able to count them because we had a graph. We were able to identify the y-intercept by looking at this line. But today, we are going to be talking about something a little bit different. We are going to be learning how to write an equation in slope-intercept form if given 2 points, and only 2 points. We're not going to be given a graph for today's skill. We're only going to be given 2 points. So let's talk about how we do it. But first, let's recall the steps that we took in writing slope-intercept form given the slope and a point. The first thing we did was we substituted the slope into the equation y equals mx plus b. Then we used the point x comma y by substituting into slope-intercept form to then solve for b. And then we were able to bring it all together and write a slope-intercept form to graph. That's when we were given the slope and a point. But today, we're going to be talking about how to find the linear equation slope-intercept form when given 2 points. Our steps are going to look very similar, but we have to tweak them ever so slightly. So please have out your notes. Let's jot down the steps to take. So when we are writing in slope-intercept form, given 2 points, we are going to do the following. The first is we have to calculate the slope and then substitute the slope into the equation y equals mx plus b. Since we are not given the slope this time, we're only given 2 points. But we know that we can calculate the slope between 2 points. It's a change in y divided by the change in x. After we then calculate the slope, we're going to have a slope value. We're going to have a value to substitute for m. Well, we're then going to choose a point, x comma y, and then substitute into slope-intercept form to solve for b. The reason that we're able to choose a point is because, well, we're given 2 of them. We're given 2 points. So we have to choose a point. Now, it does not matter which point you choose. In some situations, one coordinate point may be easier and more efficient for us to use. That's totally fine. It does not matter which coordinate point we use because both of these coordinate points are on the line. So we're going to choose a point x comma y between the 2 we are given and substitute those values in slope-intercept form to solve for b. And then we're going to do it just like before. We're going to write a slope-intercept form in order for us to graph. We're going to piece it all together. So again, first step we have to do, calculate the slope and substitute the slope into the equation y equals mx plus b. Then we're going to choose a point, x comma y, by substituting into slope-intercept form to solve for b. Then we're going to piece it all together, and we're going to write a slope-intercept form to graph. Let's go through an example. Again, writing in slope-intercept form, if we're given 2 points, we are given that the points 0, 4 and 2, 6 are on the line. Let's think back to the steps. The first step we said we need to do is calculate the slope. We want to have the slope in slope-intercept form. So let's calculate it. Remember, it's the change in y over the change in x. If we go to our coordinate points, we can label them x1, y1, x2, y2, and we can substitute the coordinate values into our slope formula. We end up with 6 minus 4 divided by 2 minus 0. When we simplify, we get 2 over 2, and we know we can simplify 2 over 2 to be 1. Therefore, the slope of this line is 1. The second step is to choose one of these 2 points and substitute it into our equation slope-intercept form, y equals mx plus b, to solve for b. Well, again, it does not matter which coordinate point we use. Come on. Come on. No. There we go. So we have y equals mx plus b. We can substitute in a coordinate point. We substitute it in 2 and 6. If I highlight it for you, it'll help you out just a bit. So the 2 is our x value. The 6 is our y value. And now we're going to solve for b. We're going to subtract 2 on both sides, and we get that 4 is equal to b. Now we can piece it all back together. We have y equals mx plus b. We know the slope value is 1, and we know the y-intercept is 4. And we can piece this all together, and we don't need to have 1x. We know that we can just write it as y equals x plus 4. And that's how we write an equation in slope-intercept form if given 2 points. We calculate the slope first, then we choose one of the coordinate points to substitute into our equation. When we solve for b, then piece it all back together. You could have used 0, 4. You could have done that, and that still would have ended up with y equals x plus 4. And if you don't believe me, try it out, kiddos. You're going to see for yourself, and it's going to work every single time. Bearing we do the algebra properly, this process works every single time. I promise you. I'm going to ask that you try out a problem now. I'm going to ask you to try to figure out slope-intercept form when given these 2 points, -3, 5, and 4, -7. These 2 points are on the line. Let's remember the steps we take. Let's use our notes to help us, and let's use that previous example that you should have been writing down. Resume when you're ready to check your work. All right, so again, the first thing that we are going to do is we are going to calculate that slope. We're going to end up -7 minus 5 divided by 1 minus -3. We end up with -12 divided by 4, which is -3. So therefore, our slope is -3. We're going to choose a coordinate point, substitute it in, and we're going to calculate that b value. Now, it doesn't matter which coordinate point you chose. You could have used -3, 5, or you could have used 1, -7. Either or, you should still get the exact same answer. Again, bearing we did the algebra properly, and we have been doing this very well. So I have full faith in y'all to do this. So we have y equals mx plus b. We're going to substitute in x, y, and our slope. So in here, I use the coordinate point 1, -7. Therefore, we get -7 is equal to -3 times 1 plus b. We get -7 is equal to -3 plus b. We add 3 on both sides, and we get that b is equal to -4. Now that we have b equaling -4, we can use that and piece it all back together. We have y equals mx plus b. Our slope is -3, and our y-intercept is -4. Therefore, our final answer is y equals -3x minus 4. Fantastic job, kiddos. Keep up the great work. Please let me know if you have any questions, and I'll talk to you soon.